Okay, welcome back everyone. In the previous classes in science and physics, we covered about work. We saw the units of work. We did a few numericals related to work. I hope you all have revised that, right? Today we're going to do study about energy. Now, energy and work, they're very closely related to each other, right? But in general terms, what do we say? We usually say, that person ABC has more energy than XYZ, or we can say that X can do more work than Y, right? So what exactly do you understand by the term energy? Can anybody tell me in layman's term? When I say that so and so has more energy than so and so, what does it mean? Anyone? If I say person A has more energy than B, what do I mean? What does this more energy mean? In layman's term, can anybody explain? So Ramya, Siddhant, Sarah, Rajvi, Parth, anyone? I'm not going to only teach if you all don't respond. Sarah, Siddhant Garve, single, Suramya. What do you mean by more energy? Don't you use this in with your friends? So and so, I don't have energy today. Suramya,
Yes.
when I say I don't have more energy today, what do I mean?
Um,
Or if I say this person has more
like
energy than me, or I have more energy than you, what do you mean when you say that? Yes, Siddhant?
So maybe that A has more capability to work than B.
Right. So he's more capable of doing more work. So whenever you're doing something or playing, for example, if you're playing football, you run out of energy, whereas somebody can still continue playing. So you basically tell, right? He has more capability, he has more capacity to do, he has more capacity to play, isn't it? So we see that energy and work are very closely related. In fact, energy is defined as the capacity of a body to do work. That is what is energy. Please copy this down. Energy is defined as the capacity of a body to do work. How much of work can a body do? That is energy, right? So therefore, if a body, so you have supposing a body is there and a body has more energy, what does that mean? It can do, it can do more work, isn't it? Yes or no? Or is this very boring
Yes,
to you all?
sir.
I want you all to participate. If you participate, these chapters will become interesting. Otherwise, they're very boring, right? And what else can we imply from this? That if I do work, what am I doing? Then I am using or spending energy, isn't it?
Yes, sir.
Obviously, because it's the capacity to do work. And if I run out of capacity to do work, then I have no energy. That means that every time I do some work, I'm losing energy, right? For example, if you're running, then what happens? You're doing work, and in doing this work, you have to spend energy, right? If you're lifting weights, or let's say if you play basketball, a lot of you do, or for boys, maybe football, right? You run on the field, you work, and you ultimately spend energy. And when all your energy is over, what happens? You say you are tired or you have run out of energy, isn't it? And then we need to rest to gain our energy back, right? Is this part clear?
Yes, sir.
Please copy this down. This is a very important formal concept. If we do work, we use or spend energy. This is a very important concept. Anytime work is done, we are using or spending energy. Rajvi, are you there in the class today or not? Have you just logged in and left? Okay, done everyone? Anybody still copying? Okay. Now conversely, this is a very important concept. Please understand this. Conversely, when work is done on a body, not by a body, on a body, it increases the energy of the body. This is very important again. Conversely, so what have we said so far? That when I do work or when work is done by a body, we spend energy, right? But we know energy cannot be created or destroyed. Law of conservation of energy. We know this as a basic fundamental fact. It can be only transformed from one form to the other. Right? This is the law of conservation of energy. Right? So based on this, what happens is whenever a body, okay, for example, a person, he lifts a box. Okay, he lifts this. The person spends energy. Yes or no?
Yes.
Yes, sir.
Right? This energy that he spends, because this energy cannot be created or destroyed, this is transferred into energy in the box and stored in the box. So when the box reaches this height, okay, what will happen? This energy is gained here. And the energy that the person lost is transformed into the box and it is stored in the box. This is what we're saying. When work is done on a body, it increases the energy of the body. So for example, if I spent, right, let's say I did around 5 joules of work or energy, this is transferred over here and this gains 5 joules. And here I will lose 5 joules. Right? Is this clear? Please copy this down. Siddharth, we will discuss this now. It is just stored. We will
Okay,
see the
sir.
we will see the different forms of energy subsequently. Okay, but just remember it is stored. For example, I'll give you one another example. Have you all finished copying this? Can I erase?
Yes, sir.
All clear? Okay. Now, for
Yes, sir.
example, now let's say the same person, okay, he picks up a big stone from the ground, and this is a glass slab. He picks it up over here and he drops it on the glass. What happened?
So the glass slab can break.
Yes, it can break. Why? Because this energy is transformed and stored in the block, in the stone. And this energy gained basically shatters the glass. Okay? If the glass was here, would it break? If the stone was lying on the glass, would it break?
No, sir.
So how is it breaking over here? Because this energy is stored in the form of in some form in the stone, and when we drop the stone, this energy causes the glass to shatter. Right? Another example. We have a football. On its own, is the ball moving?
No, sir.
But when we kick the ball, what happens?
Energy
It
gets transferred
moves.
to the ball and the ball
It
starts
starts
moving.
moving. Why? Because in kicking the ball, we have to swing a foot back and kick it. So what happens is when we kick, we use some energy. Yes. And this energy gets stored in the ball. So it gains energy, which allows the ball to move forward. This is called kinetic energy, or energy possessed due to motion. Right? Why is this? Because work done on the ball gives it energy to move. So we did some work on the ball. Work was done. When work was done, we lost energy. This energy was gained by the ball, which allowed the ball to move. Because on its own, in a stationary position, the ball had no energy to move. Siddhant, is it clear now?
Yes, sir. Thank you, sir.
Right? So this is what happens whenever energy is converted from one form to the other. It can do something with that energy. It can use it to do something. It can move. It can become larger. It can start rotating more faster, whatever it might be. There are a lot of cases that may happen. But basically, just remember, whenever a work is done by a body, it loses energy. So if we see work, if work is done by a body, then it loses energy. And if work is done on a body, it gains energy. Right? Both are done. So when work is done by a body, it will lose energy. When work is done on a body, it will gain energy. Please write these examples. These are an important concept about work and energy. Without this, it becomes difficult to answer a lot of questions which are subjective in nature. Like this question, if I kick a ball, why does it move? Right? You will just say because we're hitting the ball, it will move. We're creating motion. But why is that motion created? Do you understand now? In physics term, do you understand now why a motion is created when we kick an or throw an object? Yes or no? Anyone Have you all understood why on kicking or throwing an object, it causes motion?
Yes, sir.
Okay. Done. Anybody still copying? Sarah, Siddhant, Garve, Saramya. Any concept is not clear? Sarah,
Yes, sir.
all clear? Is this concept clear?
Yes, it's clear.
Okay. Siddhant, Garve,
Yes, sir.
is the concept clear?
Yes, sir.
Okay. Units of energy. What is the SI unit of energy be?
Joules.
Joules again. Because you know it's related to work. But there can be many units of energy depending on what we're measuring. But there can be joules, calories, electron, volts, etc. But here, when since we're related to work, we say the SI unit of energy is also joules. Okay. And we can define 1 joule of energy as 1 joule is the amount of energy possessed by a body when a force of 1 Newton moves it by 1 meter in its direction, similar to what we had with work. Copy this down, please. When we had work, we said 1 joule is the amount of work done. Here it is the amount of energy possessed. That's the only difference. Instead of work being done, we are saying we possess energy. So any body which is doing work will lose this energy or in the form of joules, and work is done on it, it is gaining energy, right? Now, continuing further, the energy possessed by a body due to its motion or position is called mechanical energy. I think you've done this last year also, right?
Yes, sir.
So the energy possessed by a body due to its motion or position, there are two main terms here. Either the motion or the position is called mechanical energy. Please copy this down. So the energy possessed, whether it's going to lose it or it's going to gain it, that is the immaterial. We have to possess energy to do any work also, right? So this energy which is possessed by a body due to its motion or position, not and or, is called mechanical energy. Mechanical energy is of two types. We have kinetic energy and we have potential energy. Please copy this. This is also called KE, and this is P dot E, short forms. Please copy all this down. I will delete it and we'll start with the first one, which is kinetic energy. What exactly is kinetic energy? Like we know, the energy is the capacity to do work. So we have a form of kinetic energy, called kinetic energy, which is a form of mechanical energy. There can be different forms of energy, as you know. There's solar energy, mechanical energy, etc. Right? Yes, Parth. Okay, done. So let's study the first one, which is kinetic energy. Kinetic energy can be referred to as K dot E dot or simply K, not to be confused with Kelvin. Okay, what exactly is kinetic energy? The energy possessed by a body by virtue of its motion or due to its motion, either virtue of its motion or due to its motion, is the same thing, is known as kinetic energy. This means that if a body is in motion, it possesses right? So any body which is in motion will always have which kind of energy?
Kinetic energy.
Kinetic energy, right? Okay. For example, let us see again that let's take a window slab example. We have a window made out of glass. Okay, I have a stone over here. If I throw the stone very gently on the glass, will the glass break?
No.
No, but there is a noise when it hits the glass. But now the same stone, what if I fling it fast?
Glass will break.
Right? So that means that even though the stone measures the same mass, there was something in the motion which basically increased the energy. So when the motion increased, the energy increased, and this increase in the energy caused the glass to shatter, isn't it? Right?
Yes, sir.
One more thing we can see. For example, have you seen a water turbine anytime? We have that wheel with this kind of spokes in this and water is falling. What happens here? This causes the wheel to spin in this direction. Yes? How is that done? Because the water is flowing downwards. So it hits it with an impact and transfers its energy, which basically moves the wheel down. So all these are forms of kinetic energy which is being used, right? All these are things. Any object in motion will have kinetic energy possessed in it, which allows it to do some work. For example, again, we have a board over here, wooden board. And we have to drive a nail into it. How do we do that? We hit it with a hammer. But if we gently hit it, does the nail go inside? What do we need to do? We need to raise the hammer, right? And then strike it hard, isn't it? So this motion, this fast motion causes the energy to be transferred into the nail, which drives it inside. Yes? Yes or no?
Yes, sir.
So when the body moves fast, what happens is it possesses more of energy, more of kinetic energy, and when this energy is transferred to the nail, it drives the nail downwards, right? Please copy this down. Different examples of kinetic energy. Are you all done? Anybody still copying? Raise your hand if you're still copying. Okay. Now, factors which will affect kinetic energy. Can anybody tell me? You done kinetic energy last year?
The speed of the body.
Will speed be the right word or will it be velocity?
So velocity.
Because it's in a particular direction, not any direction, right? It's in the same direction as the force being applied. And the other will be? So we can write speed, that doesn't matter, but we're going to use the formula as V. So first is the mass of the body. How does the mass affect? Tell me something. If I throw a ball, let's say I throw a ping pong ball, okay, at you with a speed of, let's say, 10 kilometers per hour. And at the same time, I throw a cricket ball. Again, speed is 10 kilometers per hour. Which will hit you more, harder?
So cricket ball.
So the cricket ball.
Why?
So because it has more mass.
More mass.
Exactly. So the mass is more. So even though the speed at which we are throwing is the same, the cricket ball is much heavier than the ping pong ball. So because of this, the kinetic energy possessed by the ball will be much higher. So when it strikes you, it transfers a greater energy into your body and hits you with a greater impact. Now, is this clear? Why these cricket ball will hit you more harder than a ping pong ball? Right? So the first is the mass of the body. In the mass of the body, what we say is kinetic energy is directly proportional to the mass. Right? Directly proportional. What does directly proportional mean? That if the kinetic energy, sorry, let me write it the other way around. If the mass increases, that means the kinetic energy will also increase. If the mass decreases, the kinetic energy will also decrease. Please copy this down. This basically means the heavier the object, more the kinetic energy. It's as simple as that. Done? Anybody still copying? Raise your hand if you're still copying. The second factor, like we said, is the speed of the body. Okay. For example, I have two objects weighing both, let's say, 10 kilograms. One moves with a speed of 10 kilometers per hour and the other at 20 kilometers per hour. Which will hit you more harder? Obviously 20
So
kilometers.
the 20 kilometer per hour.
The speed is the more, even
More.
though the mass is same. But there is a difference in here. Kinetic energy of a body is directly proportional to square of its speed. This is a slight change. Instead of being directly proportional, it's directly proportional to the square. That means speed square will become, so Ke is directly proportional to speed into its square. So if it's moving at 10 kilometers per hour, the speed square 100 kilometers, 100 times the energy will come. If it's moving at 20, it will be 20 in square of that, right? And again, speed increases. That means that kinetic energy also increases, but to the square of the speed, or double of it. Not double, square of it. Right? When we do numericals, you'll understand this. If the speed decreases, then kinetic energy also decreases. This means that a faster moving objects have a greater kinetic energy. So the faster an object is moving, the greater will be the kinetic energy. This is why, like, if you are struck with a slow, you're supposing you're walking on the road and a car strikes you and the car is moving very slowly. Does it hit you very hard? No, right?
Sir.
But if the car is moving at a fast speed, what will happen? There'll be a major accident. This is why, because the kinetic energy possessed by a faster moving object is much, much higher. It's square of that. Please copy this down. Now, using these two factors, we will get the formula for kinetic energy. Done? Anybody still copying this? Okay. Formula for kinetic energy is equal to half mv square, where m is equal to mass of the object and v is equal to the speed. Now, according to this formula, what happens if mass is doubled? Kinetic energy is also doubled because it's directly proportional. What if speed is doubled? That means the speed is increased 2 times. Kinetic energy increases 4 times because it is the square of it. This is very important. Please write this down. If speed is tripled, it will increase 9 times because 3 squared will become this increase in kinetic energy. Whereas mass is directly proportional only. Whereas velocity is double. So whatever is the velocity increase, square it. If it's 3 times, it will become 9. If it's 4 times, it will become 16 times. Right? If it's increased twice or doubled, it will increase 4 times. And we know the unit of SI unit of kinetic energy is joules. This means, like, for example, in mass, if mass is increased from 10 kilos to 20 kilos, the kinetic energy becomes 2 times because this is into 2. Whereas if the speed increases from, let's say, 2 meters per second to 4 meters per second, again, this is 2 times the speed, right? That means the kinetic energy will be into 4 times because its KE will be 2 the whole thing square. So that is 4. Is this part clear, everyone? This is a very common question. They'll ask you the velocity or the speed of an object is tripled. By how much times will the kinetic energy increase? What will be the answer? What will be the answer if the speed is tripled?
Can you repeat?
If the speed is tripled, how much times will the kinetic energy increase?
9 times.
9 times, right? If the speed is doubled, it will increase 4 times. This is a very common question.
4 times.
Yeah, this is a very common question they ask for 1 mark. And we usually forget about it if our concepts is not clear, right? Any doubts in what we've covered so far? All clear with kinetic energy, all clear with first what is energy, then what is mechanical energy, and then ultimately what is kinetic energy. Energy possessed by a body due to its motion. And is dependent on 2 factors, mass and the speed. Directly proportional to mass and also directly proportional to the square of its speed. Right? Units is joules. And formula for kinetic energy is half mv square. So mass will be given to you, speed will be given to you to find kinetic energy always. Without that, you cannot find out kinetic energy. Just by giving speed or just by giving mass, I cannot tell you to find out kinetic energy. Always these 2 factors will be taken into play. Right? Any questions?